welcome back to part 2 of our theoretical book for electromagnetism. So let's look at question 1 from section A. A charged particle is situated in a region of space. It experiences a force. So first, that there is a charged particle. It experiences a force when it is in motion, only when it's moving. So when your charged particle is moving, this means that there is a current. Okay, therefore it can be deduced that the region of space is located within. So you want to have a force, you want to have a current, it must be within a magnetic field. Okay, remember there must be the 3 requirements before a force can come into effect using a Fleming left-hand rule. The diagram shows a beam of electrons approaching a magnetic field. So you have a magnetic field going downwards. What is the effect of the magnetic field on the electrons? So your electrons go here, means your current goes here. Remember when we use our Fleming left-hand rule itself, Fleming's left-hand rule, your current I is used for your positive charges, not electrons. So when electrons goes to the right, your current must go in the opposite direction. FBI, the other direction, magnetic field goes down, means that it is coming towards you, is deflected out of the paper. Okay, use your Fleming left-hand rule to try. Question 3. Now a charge is directed into a magnetic field. What's the direction of positive charge? So this is your magnetic field. Your magnetic field goes away from the paper, FBI, so B goes inwards. Your positive charge, so this is your current I, FBI, that means it should go upwards. Okay. 4. 3 pairs of parallel wires have currents flowing through them in the direction flow. Which type of force does each pair of wires experience? Now, in your notes itself, you all would have already have a very quick understanding what will happen. So if it's So let us work out from the basic fundamentals. So when you use your right-hand grip rule, let's assume we take this wire, you use your right-hand grip rule. This wire here will experience a magnetic field that is coming out from it based on this wire. Okay, so FBI, so this is your B. FBI, B is coming out, I is going up, means that this wire is going here. So if you repeat the same thing from here using a right-hand grip rule, this will have a magnetic field that is going in towards FBI. So it shows that the force is coming here. So what happens when they are flowing in the same, when the current is flowing in the same direction, they will be attracted. When they're flowing opposite direction, they will repel. You can do the same working from fundamental itself. Similarly for Z, they'll be attracted. So answer is B. Okay. Question 5. A long wire is wrapped along 2 wooden rods. A large current is passed through the wire in direction shown in which 2 pairs with the wire attract each other. So we know that for them to attract, they must flow in the same direction, as we can see above here. They must flow in the same direction. So which one flows in the same direction? L and M, yes. J and K, yes. So answer will be B. Only these 2 flows in the same direction. Okay. Okay, let's move on to section B, question 4. So there is a proton. Proton is a positive charge, so we know that the current goes this way. Magnetic field is directed into a plane of the paper. So B is going into the paper. So FBI, using your Fleming left-hand rule, B goes in, I goes towards the right, should goes upwards for the force. So if we draw the path should curve upwards. Next, now is electron. Remember electron, the current means in the opposite direction. Magnetic field goes into the paper, FB goes in, I flip around, it goes down. B, suggest 2 ways in which the direction of the forces acting on the proton and electron inside the magnetic field can be reversed. So you want to reverse it, what can you do? Reverse the direction of the current. Number 1, so either the proton or electron should enter the magnetic field from the right, or you can reverse the direction of the magnetic field. So it keeps FBI itself, the force, the magnetic field, and the current itself, they are all at perpendicular to one another. If you want to change one of them in the direction, you have to flip either one of the other 2. Okay. So with that itself, we will end part 2 of our theoretical book for electromagnetism.